Hello and welcome back to Chemistry, It Is All That Matters, and today we are going to continue our journey through stoichiometry, and in this case we are going to look at how to change grams of one substance to moles of another substance in a balanced chemical equation for any chemical reaction. So let's look at two examples of how to change grams to moles. So here we're going to look at our first sample problem, and our first sample problem is based on a synthesis reaction. How many moles of salt, NaCl, are formed when 15 grams of sodium are combined with an excess of chlorine? Now basically this is telling us that we're starting with 15 grams of sodium. The excess chlorine tells us that there is enough chlorine to complete the entire reaction, and we are going to look for how many moles of salt can be produced in this process. So we need to begin with a balanced chemical equation. So here we start with the basics, sodium, Na, being combined with chlorine, reminding ourselves that chlorine is one of the diatomics and therefore must be Cl2 in its gas state, and the salt that forms is NaCl. And for this case we need to balance, and right now we're lacking 2 chlorines on the right, on the product side, so we're going to add a coefficient of 2 in front of the salt molecule, but this changes the number of sodium to 2 also, so we're going to add a 2 coefficient in front of the sodium. Now from our reading of the problem, we see that we have a situation where we have 15 grams of sodium at the start. So that is our starting point for this problem. So 15 grams of sodium is our start. And what we're going to look at for our end, we are looking at how many moles of salt, how many moles of NaCl. So that becomes our end. So when we label our start, what we have, and our end, what we want, we're looking at converting from grams of sodium to moles of salt. So once we have this laid out, I always have my students use the roadmap, and the roadmap doesn't change. What changes is where we're going to start and stop. So if we begin with the roadmap grams to moles to moles to grams, grams to moles, moles to moles, moles to grams, we realize that for this problem we are not going to go all the way to grams. We are simply going to go to moles. So we're going to need two conversion factors, grams to moles and then moles to moles. So we begin with that 15.0 grams of sodium, and the first thing we want to do is convert grams of sodium to moles of sodium. So we want 1 mole of sodium as compared to the grams of sodium, which comes from the gram formula mass or atomic mass unit from the periodic table. We get 22.99, so I'm going to round to 23. And we remind ourselves that 1 mole is always equal to the molar mass, and the molar mass is always equal to the mass of the formula or the mass of the atom from the periodic table. We now need to change from moles to moles. And what we use to change from moles of sodium to moles of salt is what is called the mole ratio, where we are going to use the coefficients from the balanced chemical equation in a ratio to convert from one substance to another substance. So we're trying to cancel moles of sodium, and we want to get moles of salt. So the substance we want to end with is on the top in the numerator, and the substance we're trying to cancel goes in the denominator, and we draw the numbers from the balanced chemical equation. So there are 2 moles of salt produced for every 2 moles of sodium consumed, and this is our basic calculation steps for conversion from grams of sodium to moles of salt. So our calculations become 15.0 divided by 23 divided by 2 multiplied by 2. Numbers in the numerator are multiplied, numbers in the denominators are divided, and our final solution is 0.652 moles of salt. And we had 3 significant digits in our original question, so we need 3 significant digits in our final solution. 0.652 moles of salt. So let's look at a second sample question, and here we have how many moles of propane C3H8 are consumed by combustion and 7.5 grams of water are released. So what we have going on here is a combustion reaction, and our combustion reaction is propane C3H8. Combustion always includes the burning of the substance or the hydrocarbon in oxygen, and we will always have a release of products of carbon dioxide and water. Now right now we're looking at 3 carbons on the reactant side, so we're going to put a 3 in front of the CO2 to give us 3 carbons. We need 8 hydrogen, so we're going to put 4 in front of the water. And if we look at this, 3 times 2, 6 oxygen, and 4 times 1, 4 oxygen, that's a total of 10 oxygen on the product side, so we need to put a 5 in front of the O2 on the reactant side. Now once again, what we're looking at is a situation where we are going to start with 7.5 grams of water, and we are going to end with how many moles of propane. So our start is going to be over here, 7.5 grams of water, and over here is our reactant being the end point, how many moles of propane. So once again, we lay out our roadmap for stoichiometry: grams to moles, moles to moles, and moles to grams. And again, we are starting with grams and ending with moles, so we will not need this last step, conversion factor to grams. We're simply going to go grams to moles, moles to moles. So once again, we need 2 conversion factors. We begin with the 7.50 grams of water. We are going to convert to moles of water by getting rid of grams of water, and 1 mole of water is always equal to the atomic mass or gram formula mass of the molecule. So water, 2 times 1 is 2, 1 times 16 is 16, and this gives us a mass of 18 grams for our molar mass. So our 1 mole is equal to 18 grams. Now we're going to use the mole ratio using the coefficients from the balanced chemical equations to convert water to propane. So we want propane, so that goes in the numerator. We're trying to cancel water, so that goes in the denominator. We get our values from the balanced chemical equation, so 4 moles of water, and because there's no coefficient in front of the C3H8, we know that value is 1. So now we have our problem laid out. We cancel grams, we cancel moles, and we're going to end up with moles of propane. And so when we calculate, it's 7.50 divided by 18 divided by 4. Numbers in the numerator are multiplied, numbers in the denominator are divided, and this gives us a final value of 0.104 moles of propane, C3H8. So hopefully this gives you a little more insight into converting during stoichiometry from grams to moles, and this is a 2-step stoichiometry conversion using the mole ratio from a balanced chemical equation. Keep working on your chemistry.